All right, welcome back to my YouTube channel, Master Tutorials, where mathematics literacy begins. Please do want to subscribe to this channel. All right, so this one is sample question 3. That's our last sample question. Further calculus, Math 203. So, which says question 3a, given that e to the power x equals to evaluate e to the power 4x minus 4 to the power 2x. So how best can we solve this? So now we are to solve so that we can deduce this e to the power x equals to, then we substitute the value of e to the power x inside the expression given. So now let's see. If I have e to the power 4x minus 4 to the power 2x, now I can write this one as e to the power x, or to the power 4 minus 4 to the power x, or to the power 2. Very, very simple. So now e to the power x equals to 2. I can write, but e to the power x equals to 2. Wherever I see e to the power x, I substitute in 2. So I get 2 to the power what? To the fourth power minus 4 e to the power x, which is 2 to the second power. Now 2 raised to the power 4 means what? You have 2 times 2 times 2 times 2 minus 4, 2 times 2, right? So now this one, 2 times 2, 4, 2 times 2, 4, so you get 16 here. Minus 4 times 2 times 2, 4. Then you have 16 minus 4 times 4, which is 16. 16 minus 16 gives us 0. So which is very, very simple and interesting as well. So now let's move on to question 3b. Question 3b. Question 3b. Find the derivative of y equals x to the power x for x is greater than 0. So now let's see how best we can solve this question. So I have y equals x to the power x. So now we can introduce our lim function so that we drop this x down. So I get my ln y equals ln x to the power x as that. Then, all right, so let's continue. Ln y equals ln x to the power x. So ln, I said ln is the same thing as the logarithm. That's the natural log. So we are using the same properties as the logarithm. So now here x drops down. So I have ln y equals x ln x. So now here we have to what? Differentiate, right? We are finding for the first derivative. So now here we get to differentiate ln. I told that it's 1 over y times what? Y prime, right? Which means we are using the implicit differentiation. Then now here I have x here, I have x here. So functions upon functions, right? So now here, how best can we solve this one? Then we have to use what? Our product rule. So now let's see, x ln x. How do you differentiate x ln x? So this one is my u, this one is my v. So I get u dv over dx plus v du over dx. So my u is x times my dv. My dv is ln x. Then how do we differentiate ln x? I get 1 over x times the variable inside. So the variable inside is x. Then I differentiate, which means I get 1 plus my v is ln x. Then times my differential of u with respect to x, which means if I differentiate u with respect to x, I get 1. Now this guy cancels that. So I get 1 times 1, which is 1. Then plus, then x times 1 is ln x. So my answer will be what? 1 plus ln x. So I have 1 plus ln x. Right. 1 plus ln x. So now here, let's proceed. My LCM is what? Y. So I have to multiply through by what? Y. How many times here? 1, 2, 3. So I multiply through by y. So I have y times 1 y times y prime equals y times 1 plus y times ln x. So this guy cancels, and I get y prime equals y times 1 is y plus here I get y ln x. But my y equals x to the power of x. So now let's see x to the power x. So our y is x to the power x. So my y prime equals x to the power x. So I get x to the power x, then plus x to the power x ln x. So therefore, y with respect to x equals x to the power x plus x to the power x ln x. Or better still, you can say that you can factorize x to the power x out. So my y over x must be equal to x to the power x out. Then I'll get to 1 plus ln x. 1 plus ln x. So this one too is very, very interesting, very, very simple and trivial as well. The reason why this time around ln x is not going to 0, it means that we have this variable x inside. Do you understand that? So now we have to differentiate this x, right? You have to differentiate this x. Ln x is different from what's ln 3. You understand that? 1 over 3 times the differential of this 3, the 3 will get to 0. At this time, the differential of x is what? 1. Mind you, are differentiating with respect to what? X. Alright, let's move on to question 3C.